What's up, guys? Today we're going to be explaining graphs.
So to find the velocity in the displacement versus time graph, you're gonna need velocity equals delta x over delta t, and then to find it, you're gonna do velocity equals 50 m over 30 seconds, and that's gonna equal 1.6 meters per second. Things you can determine by looking at the graph is whether the slope is positive, negative, or if it's not moving, like in this graph right here. That's positive. The different shapes tell you whether it is a constant velocity, whether it stops, or the velocity is negative. In this graph over here, the slope is curved and the velocity is not constant, although the object is accelerating. And then on this graph, the graph has a constant velocity and a positive slope.
To find an acceleration over a velocity over time graph, the equation would be acceleration is equal to delta v over t. V corresponding to velocity and t corresponding to the time. So A would equal to 10 divided by 5. 2 meters per second squared because it is acceleration. Alright, to find the displacement of a velocity over time graph, we need to find the area under the slope. This is equal to 1/2 base times height. As you hear, the base here is 5 and the height is 10. So the equation would be 1/2 5 times 10. This will equal to 25 meters for the displacement. A shape under the graph is a triangle, which again, like last time, tells us the displacement of the object that is moving. And something else that this graph could tell us is the velocity at which something is going by a point. Here is 1 second, and it would be going about 2 meters per second.
To find the acceleration, you look at the graph. The acceleration here is 4 meters a second squared. To find the change in velocity, you need to find the area of this space, which would be 4 times 5, which would be 20. The equation for this is delta V equals acceleration times time. On a graph like this, you have multiple different accelerations. Here, your acceleration is 4. Here, your acceleration is 2.5. And here, your acceleration is 1. If you try to find the change in velocity, you would come up with a shape that looks roughly like this.